answered your question. If I haven't, please just throw more light so that I can talk more about it. And if anyone present in the webinar room can also answer to his question, that would be really nice. That would be really nice. Okay. So yeah, he's talking about the power plant. Yeah, and Mr. Singh is talking about modular refinery. So like I said, the assessments you are doing, since you already have an environmental impact assessment, what you need to do is to benchmark the IFCU resource efficiency requirement with what is available in your environmental impact assessment. So since you say you're looking to do ESDD, that's environmental and social due diligence, that will take care of that. Yeah, it will take care of the fact that you have done an environmental and social impact assessment, and now you're doing an environmental and social due diligence. So it will check to see whether the performance standard 3 is adequately taken care of, and if it is not, it will show the gaps. So the ESDD, you just be a little patient for the ESDD to x-ray your document, or you can even do the checks yourself. Look at your environmental and social impact assessment and check what the performance standard is for performance standard 3, and just do a table, show the performance standard 3, the assessments that you have done, what it captured, and then the last column can be the gap. What is the gap identified? That's the starting point for you to be able to see if you are compliant or not. So I will not want to dwell more on that. Let's go straight to 11B. I hope we're all on the same page. So let's go straight to 11B. We are still on resource efficiency and pollution prevention for investment projects, and the performance standards and what it entails, what it requires, and all that. So the next we are going to center upon in this next webinar. Just keep writing your questions. I will look at them later, okay? So it's resource efficiency, greenhouse gases, water consumption, pollution prevention, and under it we have those sub-points, okay? So I'll go straight to the greenhouse gas emission. So for your project, you have to look at the cost-effective ways to use the project-related greenhouse gas emissions for each project. So you look at the engineering design or the engineering options that are available to you. You look at them and do a small analytical quantification of your greenhouse gas emissions. You know, there are quantification approaches. We have different approach for quantification, like the one for Intergovernmental Panel on Climate Change. There is a quantification model that is there, so you can use that for, or you can get an expert consultant to do that. But you can actually go ahead and see what are the cost-effective options for you to reduce your GHG emissions during the design and operation of the project. So the proponent actually have to consider the alternatives and implement technically and financially feasible approach for these cost-effective options. Okay, so for instance, an alternative project location can be considered, or adoption of renewal, adoption to see how you can do your renewals for low carbon, or let's say renewables of low carbon energy sources. And then it depends on the project. You can check on sustainable agriculture, you can check on forestry and livestock management practices, you know, the reduction of fugitive emissions, and the reduction of gas flaring, which is for major projects like the refineries or the oil fields. So you should use this GHG quantification checks on your technology and see how you can have, you know, the knowledge or see what is available in accordance with internationally recognized methodologies and good practices. So for projects that are expected to produce more than 25,000 tons of CO2 equivalent annually, you have to quantify for direct emissions and indirect emissions, because sometimes like we have a project we're working on in Africa where there are other projects in the same vicinity emitting greenhouse gas emissions. So you can have your project greenhouse gas contribution, which is a direct emission. You can also have indirect emissions associated with the off-site production of energy used by the project. So this can be considered. So for the clients will quantify direct emissions from the facilities owned or controlled within the project physical boundaries. Okay, that is project-induced changes in soil, carbon content, or above ground biomass, and project-induced decay or organic matter that may contribute to direct emission sources should be included in this emissions quantification, where such emissions are expected to be significant, as well as even indirect emissions associated with the offsite production. Okay, so that's about greenhouse gases. If you have questions on that, we can dwell on it, but the questions are really slowing us down, so I just want to clear on that before we proceed. Yes, I see your question. Indirect emissions can come from other sources, or associated with energy production and all that. Yes, different from the direct emissions, which will be from the boundaries, the physical boundaries of your project. Okay, so let's go to water consumption. Water consumption is usually associated with water usage for your project. Some projects have high level water demand, while other projects have less water demand. So this may influence the location of the project in some instances, but the project is, when the projects will have a high level consumption rate for water, you can adopt measures that avoid the water usage, but in most cases it's impossible. So to reduce rather the water usage. Don't forget our terminology: avoid, but where impossible, you reduce or minimize. Those are the mitigation terminologies we have been using. Okay, so if you can avoid, you can reduce water usage so that the project's water consumption does not significantly impact or have adverse impact on others. You are not the sole owner of this natural resource. So you have to see measures where you can reduce the water usage. There are technologies modifications. There are maybe reusing technologies that you can consider for the project. For instance, use of additional technically feasible water conservation measures within your operation, is a way. And also you can use alternative water supplies or water consumption offsets to total demand for water resources for your project. And also you can check alternative project options, project technology or location. We spoke about location. So you can locate your project near a water body, for instance. That can be a catch for the location, as against on a dry land where you have to draw from the groundwater. So this could alter the project design or even the decision-making processes. So we'll go straight to the pollution prevention. We'll talk about waste. We'll talk about hazardous materials management and the pesticide use and management. Okay, you have to reduce, avoid, again, come back to our terminology, avoid the release of pollutants, or when avoidance is feasible, minimize or control the intensity, and the mass flow of their release. This can be contained. It can be capped so that the mass flow of the release is either reduced or dealt with before it's released, or it can be controlled. This applies to the release of pollutants to air, to water, and land due to routine or non-routine or accidental circumstances. Because sometimes you routinely discharge effluents into the water bodies. Sometimes it may not be routinely, maybe due to some certain activity, project activity, and sometimes it can be accidental discharge. So all of this have to be put in place if it occurs, or it has to be in the plan so that when it happens, you already have a plan to address all of this. Okay, so still talking about the pollution prevention. Is that where we are? Yeah. So your pollution prevention mechanisms should also look at the community's immediate community where you're operating, or the country entirely, or the region. It can even be transboundary. It can be transboundary. So, and there are relevant transboundary laws to curtail transboundary pollutants, like the Convention on the Long-Range Transboundary Air Pollution, Convention on the, yes, I think I got it, Convention on the Long-Range Transboundary Pollution. I think it's centered on air. Okay, that has provision for how this can be managed to a long extent. So when these pollutions are bound to occur, either routinely or non-routinely or accidentally, who is responsible for the mitigation? Who is responsible? Because sometimes there are historical pollution before a project comes to be. If you are considering to have your project implemented in an industrial park, for instance, where other projects have already been existing, you will have some historical pollution that is in the record. So in such cases, who is responsible for the mitigation? I would like us to interact, because this is an interactive session. Who is responsible for the mitigation of already existing historical pollution for a project, for instance, in an industrial park? If you can share with us, it will help. Okay, yeah. Okay, polluter pays. Okay, sometimes the polluter pay principles can be cumulative. It may not be from a point source where you can say this is the polluter. So the polluter pays principle may not 100% apply, even though yes, it is very relevant, but it may not be applied 100%. Where there is a cumulative contribution of maybe greenhouse gases in a particular industrial park, you can, yeah, you can look at what options are available. It can be cumulative polluters, like somebody just said, cumulative polluters should pay cumulatively. That is correct. So, but for you, who is looking to get finance and who is developing a document that will be compliant with the lender's requirement, for the where historical pollution such as land or groundwater contamination exists, you will seek to determine whether it is your responsibility for mitigation measures. That analysis has to be done. If it is determined that you are legally responsible, then these liabilities will be resolved in accordance with maybe your national laws or international law, or sometimes national laws don't capture that. You have to now check the international guide, like the EHS guideline of the World Bank. Okay. So to address potential adverse project impacts on existing ambient conditions such as air, surface, and groundwater and soils, you will consider relevant factors, including, for instance, existing ambient conditions, the assimilative capacity of the environment. I mean the capacity of the environment for absorbing an incremental load of pollutants while remaining below a threshold of acceptable risk to human beings or to the communities or to the environment. So you have to check the finite assimilative capacity for the environment. You have to check existing land use and the future land use and make some projections or predictions as to the capacity, the bearing capacity of the environment. You have to also check project proximity. How near or how far is your project to areas of importance to biodiversity? So the potential for cumulative impacts with uncertain consequences is huge in most cases. So this has to be put into consideration. Okay. So in addition to applying resource efficiency and pollution control measures as required, the project has the potential to constitute a significant source of emissions, actually. So in an already degraded area. So you will have to consider additional strategies and adopt measures that avoid or reduce negative effects. So you reduce your own contribution to such existing pollution. So these strategies can include project location alternatives, or emissions offsets. So these have to be looked into. So for waste generation, it can be hazardous or non-hazardous waste generation for a project. So for as much as possible, you have to avoid the generation of hazardous waste, most importantly. Where you cannot avoid it and you have to reduce, don't forget our simple analogy, avoidance. If you cannot, you reduce, okay? So, but for waste specifically, apart from reducing, you have to think about to treat. You have to treat or to destroy the waste or dispose in a manner that is environmentally sound, in an environmentally sound manner. That includes the appropriate control of the emissions and residues resulting from the handling. For instance, incineration. When a waste has been incinerated, how do you dispose of the ash? That kind of a thing. What landfill? Who are the managers of the landfill? Or who do you dispose to? Who are the waste collectors that come to collect hazardous waste? And do they show you a chain of custody for the final destination of the waste and how it is going to be handled? So all of this in the planning stage have to be captured in a document. So when it is a third party that is handling the waste, you have to use you have to check the reputation and the legitimacy of the enterprise, whether they are licensed by relevant government regulatory agency, and so on and so forth. So like I said earlier, final destination of the waste has to be of concern. Is the responsibility of the proponent to check the final destination of the waste. So hazardous materials are sometimes used as raw material or used as products by the project. So you have to avoid or minimize and control the release of the hazardous materials. In this context, the production, transportation, handling, storage, and use of hazardous materials for project activities has to be assessed. Okay, you have to, the proponent have to look at less hazardous substitutes for a particular material. When it has to be hazardous materials intended to be used for manufacturing and all that, you can check on the less hazardous materials in accordance with the international standards, for some banned chemicals or materials that are used as raw materials for projects. Some are banned. You have to look at the laws regulating the use of hazardous materials as they go on. So the performance standard also stipulates that the proponents have to avoid the manufacture, the trade, and use of chemicals and hazardous materials that are already banned or already phased out, because most hazardous materials are phased out due to their toxicity, sometimes to living organism, due to environmental persistence, it could be a factor, potential for bioaccumulation could be a factor, or potential for depletion of the ozone layer. So these are provisions in the Stockholm Convention that you can take a look at and benchmark your hazardous materials with the provisions in the Stockholm Convention, and then build up a plan on how this is going to be managed. Okay, so yeah, I can see your comments, but let me just finish up with the slide, then I will take them. Okay, so the use of pesticide and how to manage the use where appropriate. You have to formulate what we call the IPM or the IVM for pesticide use. The IPM is the Integrated Pest Management Plan that you need to have, or Integrated Vector Management Plan or approach for targeting economically significant pest infestations and diseases that could be an issue during the project implementation. So these have to be captured in the document, and you have to check the plan you have versus the requirements of the IFC to see if these things are captured or not. So your program, your IPM program, IPM is Integrated Pest Management Program, or IVF as you like, should integrate or coordinate the use of pest and environmental information along with available pest control methods, including cultural practice or biological approach or genetical approach. As a last resort, it could be chemical approach, but there are so many approaches for dealing with pests which you have to review in your documents and see which approach will be adopted. There are cultural means in local communities for dealing with these issues as well. So the last resort will have to be the chemical approach because of obvious reason. So where you have to use the chemical approach, so you have to select the chemical pesticides that are low in human toxicity. Pesticide low in human toxicity have to be a priority option in the selection process, and should be known to be effective against the target species, not and have minimal effects on non-target species, so that you don't use one problem to create another one, in that kind of simple analogy. So it should be species targeted, just like you go to the hospital and you're being tested for maybe an infection, and there has to be a sensitivity test to know what antibiotics is more suitable for that particular causative organism, for instance. So it's the same principle that applies here. So the client has to design the pesticide application to avoid damage to natural non-target species, and where you can avoid or minimize it, avoid the risk resistance in pests and vectors. Okay, so the handling, the storage, components of the materials or pesticides or chemicals, as the case may be, have to be taken into consideration. In most cases, it is advisable to minimize storage, but where it cannot be minimized, standard practices have to be taken into consideration. Okay, so there are local laws that captures this, and also international laws that capture this issue. So it's to check, to benchmark, to see what laws should be applied for the planning, and also the handling or proper handling of these chemicals. There have to be some training for the staff that will be handling it. This should be documented as a guide for the project implementation. So I'll take your questions very quickly. so that we can go on. Yes, somebody just said, yes, pesticide use with proper equipment. Yeah, handling with proper equipment for storage and application. That's correct. Thank you very much for that comment. So more questions? This will end the 11B webinar on resource efficiency and pollution prevention. If you have major questions, you can send to my email, comfort@richflood.com, and we'll be able to discuss the challenges with you. We can develop some plans suitable for your project to handle some of these aspects according to the requirements. So you can let us discuss your project and do some gap analysis. We can work with you in that regard. So I see some question here. Dawn says how